Even if you're not a science fiction fan, you can't help but hear about all sorts of cool kinds of imaginary gadgets, from lightsabers to time travel. However, the reality is that almost everything you see in science fiction movies is, scientifically speaking, actually really pretty bogus. They're not real. But I have some good news. There's one physics concept in the pantheon of great science fiction plot devices that is totally real. This physically real thing is antimatter. Antimatter was predicted in the 1920s and discovered shortly thereafter. Since its discovery, scientists have been able to make antiatoms, including antimatter hydrogen and helium. Antimatter is science fact, not fiction. So what are some of the properties of antimatter? You might be surprised that antimatter is governed by the same rules as ordinary matter. There's nothing all that unusual about it. You can make an antimatter world, an antimatter universe, even an antimatter me. Well, look, there's anti-me now. Hello, anti-me. Hello, me. So how the heck... Wait, that might not be a good idea. What's the problem? Well, remember what happens when you combine matter and antimatter? Oh, yeah. I see what you mean. So tell them about it. One interesting thing about antimatter is what happens when it combines with matter. That's when things get exciting. You've probably heard Einstein's famous equation E equals mc squared. If you've cared to dig in what it means, you've heard that it means that energy is equivalent to matter and vice versa. And that's true. However, that statement is incomplete. When we convert energy into a particle of matter, we must at the same time create an identical number of particles of antimatter. It's always the same. So what Einstein's equation means is that you can convert energy to matter and antimatter, and you can combine matter and antimatter to make energy. Now let's take another look at Einstein's equation. E stands for energy, m stands for mass, but the c squared term is just a number, actually a very big number. In the usual metric system, it is a 9 followed by 16 zeros. This means a little mass is a lot of energy. We can work out just how much. Suppose we had an antimatter paperclip and touched it to a matter paperclip. Can you help me out, Auntie-me? Sure. We'll take these matter and antimatter paperclips and touch them together. The energy that would be released when these two things are combined is enormous. About 20 times as much energy as it takes to lift the space shuttle into orbit. That sounds dangerous. I think I'll get out of here. Bye. Good idea. I'll see you later. It's a natural question to ask if antimatter is dangerous. The answer is no, or more accurately, we can't make enough to be dangerous. The easiest way to answer this question is to visit the Fermilab anti-proton source, the world's most powerful antimatter production facility. This facility made antimatter protons for about 25 years. In fact, we worked very, very hard to make as many antiprotons as possible. So how many antiprotons does 25 years of tireless effort bring us? Well, if you were able to store all the antiprotons ever made and combine them all at once with an equivalent amount of matter, we'd have about enough energy to warm the coffee in this urn from room temperature up to something drinkable. That's just not a lot of energy, and it clinches the argument that mankind's study of antimatter poses no credible danger. However, antimatter does pose one very interesting mystery. We believe that matter and antimatter are created in equal quantities from energy. In the beginning, when the universe was much younger and hotter, the energy available at that time should have created matter and antimatter in equal quantities. Yet today, our universe consists entirely of matter. Why is that? The answer is rather simple. We just don't know. In fact, this question is one of the most important puzzles of fundamental physics of the 21st century. As usual, a mystery of this magnitude results in many physicists working on it. We haven't found the answer, but we will. And when I hear something, I'll be sure to let you know. Hey, me. Yeah? Good job, guy. High five.